An astronaut drops a hammer from 2 meters above the surface of the moon. If the acceleration due to gravity on the moon is 1.62 meters per second squared, how long will it take for the hammer to fall to the moon's surface? Okay, so let's write down what we know. We know the displacement of the hammer. It's going to be negative 2 meters since it is downwards, so it's dropped from above the surface down to the surface. We know the acceleration due to gravity on the moon. It is negative 1.62 meters per second squared. We know the initial velocity of the hammer. We're assuming that it's dropped from rest, so that initial velocity is 0 meters per second. We want to know how long it takes for the hammer to reach the surface of the moon. So we want to know the time. So we can use this equation. Displacement is equal to initial velocity times time plus 1/2 times acceleration times time squared. We know initial velocity is 0, so this term will be 0. We'll have displacement equals 1/2 acceleration times time squared. Multiply both sides by 2 over acceleration to leave us with 2 times displacement over acceleration equals time squared. Now let's plug in some values. So we know our displacement to be negative 2 meters, and our acceleration to be negative 1.62 meters per second squared. Again, the negative is because the acceleration is downwards, and so is the displacement. So 2 times negative 2 divided by negative 1.62 is equal to positive 2.47-ish, and the units there will be seconds squared. Now if we take the square root of both sides of the equation, we'll end up with time equals 1.6 seconds when we round to 2 significant figures. So we only have 2 sig figs here, which means that this should technically only have 2 sig figs. I just kept one extra figure to get a more accurate final answer. And then in our final answer, we only want 2 significant figures. So this is the final answer for this problem.